table of values. Okay, so let's put that understanding to a test by looking at exercise 2.3 question 9. Okay, let's take a look at this question. Right? The question says we want to find the value of A and B such that the question has given us the solution, okay, to this inequality. So when we solve this inequality, this will be the answer. Okay, so negative 2 to 4 is the answer to x squared plus ax less than b. Right? Okay, so our question is asking us to find the value of a and b. Okay, so what are we supposed to do in this case? Okay, what we will naturally do is that when I have a quadratic inequality, we will try to solve, right? Okay, and in the process of solving, we want to place everything over to one side and then on one side to be 0. But then if we do our usual way of solving a quadratic inequality, it becomes a problem over here because with this quadratic expression, you find it a challenge to be factorizing it. Okay, because everything is unknown. Okay, A is unknown, X is unknown, B is unknown. Okay, so nothing much that we can do over here. However, okay, what we have to do in this question is that we want to do and work in reverse. We know the answer already. Okay, we know the answer is negative 2 to 4. Okay, this inequality will make us expect a happy base graph because your coefficient of x squared is positive. Okay, and since it says less than 0, we are expecting that the answer that leads to this, the way that it leads to this, will be this range over here, this bottom part here. Alright? Okay, so the graph is what we can get out of this inequality because positive coefficient of x squared, so it's happy base, less than 0, so that means it must be here, and so we're looking at this interval. Okay, which makes sense because our interval over here is between negative 2 to 4, and we know that if we are looking at this interval, we need the values to be negative 2 and 4. Agree?
Yeah.
Okay, so actually what comes in the step before this negative 2 to 4 usually, it is the factorization, right? Okay, so because of how we interpret this inequality to get our graph, and filling up the graph based on our answer over here, we can say that the factorization that we will get will have to be x plus 2 times x minus 4. Correct? It's about working backwards. Okay? And it has to be less than 0. Because we are looking at the portion of the graph that is below the x-axis and less than 0. So we are working backwards in this question. Okay? Yes?
I don't understand how you get x plus 2.
Because to get negative 2, it must be x plus something equals to 0, then x equals to negative 2, right? So work backwards, x plus 2 equals to 0. It's about working backwards. You understand? Okay. So likewise, to get x minus 4, it's because our value here is 4. So it must be from x minus 4, then when it's equals to 0, x equals to 4. That's why we get this. So it's all about working backwards now. Okay? So now that we have arrived at the factorization form, okay, we are now working backwards. So I want to do a comparison eventually to the question that we have. So we expand this expression over here, we get x squared minus 4x plus 2x minus 8 less than 0. Which simplifies to x squared plus 2x, minus 2x minus 8 less than 0. Okay? And we ensure that the coefficient of x squared only part that is consistent. It is the same, it is actually both 1. Okay, so only at this stage whereby the form is actually the same, then I can do my comparison that A is going to be negative 2 and B is going to be 8. Okay, so we do a comparison between here and here and here and here. Okay, so negative B is negative 8, so that's why B must be equal to 8. Questions? Okay, we do one more, part B. In this case, we are given 2x squared plus a more than bx. And x less than negative 2 or x more than 3 is the solution. Okay, to this inequality when we're solving it. Right? So based on what we usually will do, we place everything to one side first. That's what we can do. While I'm at it, I arrange everything in decreasing order x powers. Okay? Right? So with this expression over here, we see that the coefficient of x squared is positive. So I know that I must be having a happy face graph. Okay? And because it says more than 0, so I'm looking at solutions here and here. Because only this part of the graph, the tail ends here, will be above more than 0. Right? Okay, so because the solution says x less than negative 2, this part is the part whereby it says less than a number, so this must be giving us 2. Sorry, negative 2. And then over here must be giving us a 3. Any questions so far? Yes, Alex. I can't hear you. Okay, the coefficient of the inequality, yes, it is 2, but it doesn't matter because the roots, these are the roots of the quadratic expression. Yeah. So it doesn't matter. We ignore this coefficient. What is this coefficient? You give me, and let me finish this up. Okay. So we agree that because of this solution over here, it must be the roots of this equation. Okay. So what this will tell us is that the factorized form, okay, must be x plus 2 and x minus 3. The factorization must have your x plus 2 and x minus 3. Correct? But we know that, okay, x times x don't give us 2x squared one. Right? Because this factorization and the expansion must be consistent. Okay, so where did this 2 over here go? We just have to add it in. Because it doesn't affect how does our factorized form look like. Okay? Right? So I get this based on the roots. Okay, and then this 2 is because of the coefficient of x squared. For which I will now expand it. Here, take the number. Which expands out to be x times x squared minus 3x plus 2x minus 6. Okay, so we get 2x squared minus x minus 6. And that simplifies 2x squared minus 2x minus 1. Okay. Okay, then we can compare with the original. We will then see that our negative bx can be compared with negative 2x. So b must be equals to 2. And then this is a plus a, this is a negative 12. So your a must be equals to negative 12. Alright? Give it a little bit of time to think through this to see if you have any questions to ask.
Boy.
Questions? Yep. Why then? When you compare this and this, not should we be comparing? It must be the single x compared to single x. It's not about being in the center compared with the one in the center. Okay. So it's not about the position of the terms. It is about the x that we have. So x squared compared to x squared, x compared to x, constant term compared to constant term. Yes. Right? Any other questions? Okay. So these two questions over here really puts us to challenge ourselves about our understanding about quadratic inequality solving, because we are looking at the whole process from a backwards perspective. Okay? If you're all okay, then we look at another question. Okay, we take a look at exercise 2.3, question 11. Inequalities. So beside k is actually negative 6, we will multiply by negative 6 on both sides first. Okay? For which our inequality sign will actually flip. Because we multiply by negative 6. Okay? Then we add a 4. Sorry, my markers are dying. So adding 4 on both sides, we will get 4 minus 6k greater than 4. And 4 is definitely greater than 0. Okay, so therefore I can say that 4 minus 6k will have to be greater than 0, which is positive. Okay, just like that. Okay, next we want to look at part 2. We ask us to find the range of values of A for which fx is equal to 0 has no real roots. In other words, we're looking at this particular equation, this particular case. Sorry, let's get back to this. So what are the codes here? Negative 16 and 0, right? Less than 0 means that we look at below the x-axis, so this interval A. Okay? And therefore, it will be between negative 16 and 0. Okay? Questions? Alright, next we look at triangle. Okay, let's take some time to write down the question. Okay, in the meantime, please read the textbook. Let's look at triangle. So now we're going to learn how to apply our quadratic inequality solving or problem sum. Okay. In this question, we need to make sure, in fact, any question, we need to make sure we read every single detail of it rather than just read the end. Okay, it says that the cost in thousands of dollars, that is in C. Okay, taking note that it's in thousands of dollars, so that is for your variable C. For producing X 100 units, so X is a variable, in 100 units of laptops. Okay, in a company, could be modeled by this. Okay, so we have this equation over here, this function over here, that will be able to inform us when I produce a certain number of laptops, the cost will be a certain value. Okay, so that is what this function over here tells us. we want to reduce what? Reduce the cost. Okay, cost is referred to be C. Okay, to be below $20 million. Okay, so what we want over here, based on what the question is asking, is that we want the cost to be below $20 million. Okay, now this writing over here, this expression or this inequality over here is not quite accurate. Why? Because we need to keep in mind that C is actually in thousands of dollars. So I cannot, okay, it is not correct for me to say that my C, which is 0.03x squared minus 360x plus 100,000 is less than 20 million. Okay, this is an incorrect inequality to form. Okay, because this was supposed to be in thousands. Alright, whereas this one is in ones because it's the entire 20 million itself. Okay, because we take into consideration the entire value 20 million. So that's why this inequality is not right. And you will likely form such an inequality when you don't pay attention to the details of the question itself. Okay? So what is then the correct inequality to form? We must ensure that the way that it is being measured on both sides of the inequality must be the same. If this were to be in thousands, the right side should also be in thousands. So to convert the 20 million to be in thousands, we just have to divide this by 1,000. Okay, so that on both sides, they are now counted in thousands. You understand? Okay. Which we can then simplify it into 0.03x squared minus all this, and then 20,000. Okay, so both sides needs to be in thousands. Right? So this statement now has a different way of interpreting also. We can definitely put everything over to the other side. It is as good as saying that we want this entire expression here to be less than 0. Okay, are there questions at this juncture? In terms of how we form this inequality and how we go all the way to it. Okay? Okay, so at this juncture, what we are understanding in terms of what we are writing is that this inequality that we form is trying to get the cost to be below 20 mil. Okay? So in order to investigate how is it that the cost can be below 20 mil, we can look at this alternative inequality, which is a quadratic inequality that's less than 0. Okay? So these two, they are equivalent. Okay, by equivalent, I'm not saying that they are equal, so please don't write equal signs. Okay, by equivalent, I'm saying that the statements, the mathematical statements itself, they carry the same idea. Okay, so to solve this quadratic inequality, perhaps you may want to divide across by 0.3 in a sense, 0.03, so as to remove this coefficient of x squared. Okay, that's one way, so that you may consider doing factorization. But then I just want to push us ahead, okay, so that we don't really try to do factorization in this case. This quadratic expression cannot be factorized. Okay, you can go and try it out, but you realize it cannot factorize. So with such large numbers and also a very small group over here, what we will do is to just solve it by looking at the quadratic formula. Right, so negative b plus minus b squared minus 4ac divided by 2a okay, and then we will get this value in the square root okay. I'm giving it to truncated 6SF instead of 5SF. Reason is because so that I get extra few digits, since the question wants us to round to the nearest whole number. So I definitely need a few more, one more decimal in order for me to check. So it may not be always a hard and fast rule in terms of always doing truncated 5SF. You need to look at what is the eventual answer, okay, to decide whether you need more significant figures or not. Okay. So what is the purpose of us doing this process? Okay, don't forget we're trying to solve a quadratic inequality. The purpose of us doing this is so that we can go back to our graph, which is a happy face graph, because x squared is the coefficient of x squared is positive. Then we can see that down here will be 206.497 and down here 11773.5. Okay, and we're looking at less than 0, so it must be this part of the curve, for which looking at this interval. So the number of laptops, which is represented by x, it needs to be between this value and this value. Okay. Always go back to what the question is asking for. If you forget as you do the question, we're trying to find the minimum number and the maximum number. Okay? And then the number needs to be rounded to the nearest whole. So I say that minimum number of laptops equals to 226 and maximum number of laptops equals to 11774. Am I right? The next is it's not correct. So what's wrong?
Something is
What have I done over here? I only look at this and then I round up to nearest whole. That's all I did, which is not correct. Okay, so it's in thousands. Okay, so does that mean I just have to multiply by thousands or by 100? 100, right? Okay, so I put in 2 more zeros more. How should I be even getting these numbers before I multiply by 100? Okay, we need not go and multiply 100 over here first. Okay, we look at understanding this inequality. Okay, this inequality tells us that our number of laptops must be more than 226.497. What is the next integer that is within here but greater than this value? 227. Okay, so our minimum number should be something with reference to 227. Okay, our maximum should be referring to this number, but it must be below. Okay, so that it falls within the interval. So it must be 11773. Okay, and not forgetting that our number of laptops, okay, is measured in terms of 100 units. So therefore, I must put in another additional zeros. Okay, so we don't lose track of what we are doing. We don't lose track of the context of the entire question. Okay. Any questions? Yes, Kaden. Why I put 210? Because I need to times 100. Down here says number of laptops is in 100 units. Yeah. Yes. It is not about rounding. Okay. So just now, that was the point I was trying to clarify. It is not about taking these two numbers and rounding it off. It is about understanding it as an inequality. My number of laptops must fall between these two values. So if you look at your number line, we have 226.497 and 11773.5. Our number of laptops must be within here. Okay, what is the number, an integer that is after 226.497? 227. Okay, it's not about rounding off, it's about looking at what is inside the number line. Okay, and then this one is 11773. Questions? Okay, we look at one last one, then we can finally wrap up this topic. Wait. Okay, so we look at one more first. Okay, before we wrap up the topic. It should be bigger, right? Because question says exceeds. Okay, so we're looking at the h being greater than 3 Okay, in other words, h being equals to this. If we are looking at this entire inequality. Okay, we want to find the range of values of t. So can we solve this inequality? We can, right? So can I give you 5 minutes to go and solve this part I? Okay, 5 minutes. Okay, shall we discuss? Now, okay, can I get someone? Let's see, lucky one. Daryl. Okay, tell me what is your next step? Okay, you read it out there, right? You factorize, okay? So what is the factorized form that you get? Sorry? You took out negative 16, okay? Then t minus 3 followed by t minus 7. Okay, so this is what Daryl got. We all have this, or does anyone have something different? Are we able to get this? Okay. Yes, because it was different. Okay, so you do the quadratic formula to determine the x roots. Yes, you can do that. Okay, so if you want to do it via the quadratic formula, just make sure you label it as t equals to, because we're talking about t, minus away your negative, 160 b squared, b squared minus 1 is minus b plus minus b squared minus 4 is okay, you can do this, right? Not an issue, right? But if you chose what Daryl has done, okay, to factorize out negative 16 first and get this, that's also okay, because both will lead you to be able to draw your graph, okay, in what shape? Yeah, set base, okay, it should be a set base in this particular case, because the coefficient of your t square is negative. So it must be in this shape such that over here is 3 and over here is 7. Okay? Then now, question says more than 0. So with reference to the graph, we should be looking at this portion because this is the only part that is more than 0, in other words above the x-axis. So your range of values of t should be between 3 and 7. And hence this will be your answer. Okay? So that's why you cannot memorize. It's always think that more than means that it's outside. Okay, less than is inside. Alright, it's about your understanding about your graph. Okay, because more than 0 will mean that we're looking at the graph being above the x-axis. Okay, if you want to remove the negative, you can, but there's something that you must do. Because if you divide by negative 17 throughout, the inequality sign is complete. Okay? So there are multiple ways to go about doing this. Either you keep it in its original form, original inequality sign, change the way you interpret the graph, or you make your coefficient of t squared being positive so that you can have a